Hi, most welcome to this lab in diffraction. This part of the lab you will do yourself, and it regards the spectrometer. So in this small short video we will introduce the spectrometer to you and how you would work with it. When you come to the lab it looks exactly like this. There are 4 spectrometers, 1 in each corner. So you're all working with 1 spectrometer each in order to keep safe distance. The light sources are slightly different. They're all cadmium, so you all see the same spectral light, but how to turn them on differs from setup to setup. Most of them you just turn on power and the light will go on. It takes some time for the light to warm up, so do start the lamp when you come and turn it off when you leave. The lamp can get a little bit warm, so try to avoid to put your hand here. And then the spectrometer, it looks the same at all the setups. This is a very traditional spectrometer. It's the same type of spectrometer that Ångström used in Uppsala. It consists of 2 telescopes, and in between there is a grating. In order to do this without supervisors, we need to leave you alone with this. So please be careful with the setup and don't touch the grating, for instance. The first telescope is called the collimator. The collimator starts with a slit. You look from this side, see that there is a narrow slit, and you can adjust the width of this slit with this screw. Adjusting the slit will allow you to change the amount of light that enters and also improve the resolution. The more narrow slit you make, the better the resolution will be, but it will also be harder to see the light because there is less light. This telescope is used to collimate the light that comes through the slit onto the grating. Usually you don't need to do this adjustment, but you could know that moving this changes the focusing of this telescope. And the light that passed through the slit then be collimated onto the grating. Then when you come, it's not positioned like this, but it's actually positioned just in front of the light source. You don't need to move the spectrometer like I did. And when you now look here, you have the light going through the grating, and then we will use this telescope here to look at this light. But to start with, you can move the telescope away, and you can actually look through the grating and see. Hard for me to focus now on this, but you see the different colors, the spectral light through the grating. These are the lines that we will be looking at through this telescope. At least we see 4 different colors here, and these are the colors that we will examine. This is typical for cadmium, that you see 4 different colors. So now we've set up the spectrometer. We have the slit positioned just in front of the light source. The light source has been on for quite some time now, so it's nice and warm. Now we start to set up the spectrometer. You need to ensure that the first telescope, the collimator, is aligned with the light source. You look at the grating, make sure that it's perpendicular to the light, and we'll look into the telescope. And if we align everything with a straight line, we will see the 0th order. That is, we see all the colors go straight forward. We see an image of the slit. And when we look into this eyepiece, we see two things. We see a hair cross, and this one we focus on by moving this small eyepiece in and out to make sure that we see the hair cross nice and sharp. And we do this first. After that, we can use this knob to focus the telescope. We can focus on one of the lines. Say, if we look now, we see a red, a green, and two blue lines. Maybe one is purple, but we look at them, and we can at the same time, if we reach, we can play a little bit with the switch. We can play a little bit with the slit. If we open the slit, we see that, okay, the imaging is not so good, but we get more light, making the slit more narrow, closing it. The lines get nice and sharp and easier to define, but it's also less light. When we do the measurement, it could be good to do that in darks, and you need to compromise with your colleagues in the room. Do talk to each other. Now we make sure that we see the lines nice and sharp. We see the hair cross. Now we try to position carefully the hair cross so that it's centered on the 0th order line. Make sure that it comes in the middle of the line. For fine adjustment, you can use this knob. It will move very, very carefully, move the telescope, because you want to calibrate this. Because now we have the 0th order, and this we will measure with respect to this one. So this is your 0 degree. However, on this scale it doesn't say 0 degree, so you need to read this off and have this as 0 degree. It's a very careful scale, so you can measure precisely in 1/60th of a degree. And 1/60th of a degree is called minute. It's an old unit that's still used. So you measure how many degrees and how many minutes it is. And I will put a small, I will try to help you with some description how this so-called nanoscale works. But basically you read off first degrees and then minutes where the lines line up exactly. So now we have measured where is 0. You can loosen this screw. There is a screw in the back here, but you can tighten. And then we try to measure the lines. We see that, okay, first comes the purple line. Position that as careful as possible. Read off the blue line, the green line, and the red line. And of course, it's a transmission grating. You will get both plus and minus diffraction orders. You can do it on moving it on both sides, and you will see the same thing. The blue, the purple, the green, and the red, they appear on the other side as well. So in order to get good precision in your measurements, you should do the measurement on both sides. And what's more is that if you continue to move, the next order will appear. Now m equals +2. And here the lines get broader and slightly fainter, but also they are more dispersed. You have a better resolution here, so you can get better precision by measuring these. So you should try to measure at least 3 orders on each side. Measure these lines on each side, read off, and put it all down in the table and see. And then you can, from this, you know the lines per millimeter. This grating has, this one has 100 lines per millimeter, which means that the spacing between each line, between the slits in this grating, is 1/100 millimeters. So that you can use then to calculate with the grating formula what's the wavelength, what are the 4 different wavelengths, and you can compare that, look it up and see what are the numbers that should be. It looks simple, it's straightforward to do, and it looks like a rather old-fashioned device. However, you can get extremely good precision doing this. So at least less than 1% you should be able to get from this. So these are the measurements that you should do in this lab. You have time, you have 2 hours. Take your time, familiarize yourself with the setup, work with it, see that you see the diffraction orders on both sides and that you do the measurements carefully. If you find it hard to read this scale, there is a small eyepiece here that you can use to read off. And if it's dark in the room, maybe you want to use this light in order not to disturb your colleagues too much. I really hope that you will enjoy this lab and that you get the chance to work with this even though the circumstances are as they are. So I wish you good luck and have fun. Take care.